when a spherical fusion fuel pellet is symmetrically heated with lasers, the plasma starts out roughly spherical. Now, about 35 years ago, fusion researchers had hoped the plasma would compress in a perfectly spherical fashion. Unfortunately, nature fought back. Roughly, this is what happens. Instead of being perfectly symmetrical, the plasma ball is covered by bulges and spikes. Researchers discovered if the plasma ball was squeezed harder or faster by bombarding it with more laser energy, then the growth of the bulges and spikes was even more dramatic. It was like squeezing water in your hands. The harder you squeeze, the faster it squirts out the holes. Each spike develops its own little miniature magnetic field. At first, the magnetic field curls around the instability according to the right-hand rule. Then, spherical waves can start popping up everywhere. On their own, these bulges and spikes can naturally grow in size. They grow into jets of plasma. This detail was extensively studied with laser inertial confinement devices. Interestingly, nobody tried to use magnetic confinement to stop these jets from forming. On the other hand, in my designs, when jets like these expand outward, the situation is different. As the jets shoot towards the confinement field, the jets interact with the confinement field. Due to the MHD effect, a little, a lot, or all of the jet's energy will be absorbed by the confinement field. If only a little energy absorbed, then the burn times will be lengthened, which is good. If a lot of energy is absorbed, then the jets might be stopped altogether, which would be great. The ball of plasma would become spherical. If all of the energy is absorbed, then the plasma would actually start to compress and get smaller again. Nothing could be better, because the fusion burn would start pulsating and we become self-sustaining. Burn times could grow to days, weeks, or months. At this point, if I don't refer to something, then some fusion researchers might doubt my knowledge. Most fusion reactions produce some neutrons. Neutrons will not be stopped by the confinement field because they have a neutral charge. Only positive or negatively charged particles will interact with the confinement field. Therefore, because neutrons will make it through the barrier, all of the energy cannot be absorbed by the confinement field. On purpose, I deleted a fairly esoteric topic here. It has to do with something fusion researchers call advanced fuels. While most fusion reactions produce some neutrons, normal fusion fuels will produce a significant portion of neutrons. On the other hand, some advanced fuels hardly produce any neutrons. If my fusion power plant designs work, then they'll be more efficient when they use these advanced fuels. I could make any number of analogies at this point, like to the octane rating for gasoline. However, overall, this is an insignificant thing to worry about at this stage. In my designs, there is no doubt that an interaction will happen between the charged particles and the confinement field. In my opinion, the biggest questions will deal with engineering. We will not know how good the interaction will be until my designs are built and tested. My prediction is, after my engineers make the first good confinement field, the quality of confinement field will be something that will improve every year. Fusion scientists will study every detail of the design to improve this characteristic. Every year, something new will be thought of, and just like with computers, cars, and most other things, we'll roll out our latest design. With regard to tokamaks, there's been some talk about creating some kind of adaptive method to deal with the instabilities. What I've been describing is an adaptive method. This confinement field will naturally be strengthened by any and all of the jets of charged particles that shoot towards it. With regard to an adaptive confinement, this is how it should be done. Just place the fusion field inside a spherical electromagnetic confinement field. If I understand this correctly, then the containment field will adapt all on its own as needed. Because this is an electromagnetic process, the confinement field will adapt at the speed of light. No sensors are needed, no computer codes. When any jet of plasma shoots towards the confinement field, nature takes care of all the details. Personally, I know this will work. However, I understand that is not enough. Some people will assume that I am guessing. I understand I will have to prove it. This is one of the most important details that I will need to prove to everyone. Keep in mind though, and there is no way around this will take millions of dollars to prove. I can't build fusion power plants all on my own. I can't afford to do the experiments without financial help. And then there's the issue of regulation. Even if I had an example of the fusion power plants that I envision sitting here in front of me right now, I could not legally turn it on. If I'm correct, then these fusion power plants will work very closely to how I've described. If I've made some kind of mistake in how I've visualized all this, then this is where the monster will rear its ugly head. One way or another, the early experiments will be exciting and dramatic. They will dramatically succeed or they will dramatically fail. When experiments are conducted, safety will be the first priority. One of the first people I will hire for my lab is an expert in high voltage safety. At my lab site, the offices and labs will be in separate buildings. The offices will be above ground and the labs will be underground. There will be at least 4 main labs for the big experiments. Each main lab room will have a separate control room. During the experiments, personnel will control the tests remotely. The greatest risk will be from the high voltage impulse currents. For example, during early tests, there's a chance that certain parts of a circuit could fail in a shower of sparks. Wires could short out, capacitors could burst. But don't worry, these are ordinary hazards when you test high voltage devices. In the lab, each major piece of equipment will have its own room. The labs will have walls, floors, and ceilings made with high-density cement. That means they will be able to absorb any stray neutrons, and they will be underground. No experiment will use any highly radioactive fuels. These experiments will not create any highly radioactive waste. Neutron shielding will be used. The main lab rooms will have a metallic shield to absorb electromagnetic pulses. The power supply for all experiments will be electrically isolated, away from the public electrical grid. It will be impossible for any lab experiment to create a public brownout or blackout. Each lab room will have its own halon gas fire suppression system. Keep in mind, even if my designs work right from the start, many tests will still need to be done. This is just part of the reason I want to start my own fusion energy research and development laboratory. I want it done right. In essence, I want my lab to do these tests. I want to be there and see the proof with my own eyes. Please excuse me when I talk about the confinement field. Sometimes I use different terms. Sometimes I call it the containment field. Sometimes I refer to it as a spherical field. Sometimes I refer to just parts of the field, such as the electric field or the magnetic field or the gravitational field or the Poynting vector. Sometimes I call it the unified field. Here, I'll try to just use confinement field. Again, if I'm correct, the confinement field will be able to react immediately to any of the jets of plasma that might shoot out from the main plasma. That is why, in my fusion power plant designs, the containment field will exist ahead of time. When you think about them, these jets of plasma are very small. However, they can have a lot of energy for their size. The containment field will be able to react fast. In fact, there's no way to react faster. After all, the confinement field is electromagnetic. Thus, it will react at the speed of light. This might seem like magic to some people because, again, if I'm correct, it will appear as if the confinement field can immediately read the mind of any jet of plasma that tries to shoot towards it. In each core, there is a hot plasma. Outside the plasma is the spherical electromagnetic confinement field. Between the spherical field and the plasma is a boundary. For most people, this is where the mystery occurs. However, this is not magic. Plasma scientists have been using this kind of interaction for at least 60 years. It's just they have not done this using a spherical geometry. At this boundary, there is an equal and opposite reaction taking place. The field can push energy into the plasma, and the plasma can push energy out into the field. This is equal and opposite. In a typical power plant, even in a typical fusion power plant design, water is heated, making steam. The steam is used to drive modern steam turbines. The turbines turn electric generators, making electricity. Now, I say modern, but after 60 years of unsuccessful fusion research, for a fusion power plant, this is now old-fashioned. There is a better way. I showed it earlier. Here is that animation again. In these fusion power plant designs, when the plasma expands outwards, the pre-existing spherical electromagnetic field is waiting. By planning ahead, this field is artificially made before the fusion fuel is ignited. When the plasma tries to expand against this pre-existing field, when it pushes against this confinement field, the plasma stays hot but loses energy. The energy is not lost because the ions in the plasma are moving around in the plasma. The energy that is lost is from the bulk movement of jets of plasma. When the jets move towards the confinement field, that energy is absorbed by the confinement field. The jets of hot plasma are deflected. In this symmetrical spherical geometry, deflected means pushed back inwards. The energy lost by the plasma is gained by the confinement field. In this graphic, the outer confinement field becomes a thicker blue line. This blue line represents the magnetic fields in the confinement field. Not shown are electric fields and the gravitational fields, which are also becoming stronger. This is extremely interesting. The plasma stops expanding and contracts again. I can imagine people standing around the cores of these power plants watching this happen on monitors, completely mesmerized by this. I hope there are enough people out there that understand how important this is. If you think of yourself as someone interested in eliminating carbon pollution, then nothing should be more important to you than this detail.